Yes, class. Good evening. Am I audible to all of you? Abhinav, Alia, Anna, and Heather.
Yes, ma'am.
All right. So, yes, in the last class, we could only complete 2 questions. So, let us practice questions today from current electricity portion. So as I have told you in the last class, we'll include the circuits. We'll include the basic resistor circuits, not the difficult Kirchhoff's one and all, but basic resistance, because let us at least complete the entire resistance portion together. So few circuits we had seen today, some questions, some other questions also, let us practice it. All of you at least try. You people do not have a habit of responding. Very few students respond. At least whatever is you are getting your answer, try to respond, because when you will try it by yourself, then you will understand it better. So note it down, send me whichever option is correct according to you. And even if the option is not matching, then tell me, just write none of the option is matching, my answer is coming this. That also you can do at least till here for your practice. See, how do we solve this question? So Alia has answered, Abhinav has answered. Yes, correct. Both of them are right. They have attempted also, and they have attempted it correctly. See, you have to find out a charged particle having drift velocity. So VD is given, electric field is given. So mobility is asked. Class, is a formula based question. Yesterday, didn't we discuss this formula? Yes, Anna, right. So electric field is 3 into 10 to the power minus 10. Yesterday only I told you drift velocity is basically ratio of mobility is ratio of drift velocity and electric field. So drift velocity 7.5 into 10 to the power minus 4 by 3 into 10 to the power minus 10. So this will be 2.5 into 10 to the power 6 meter square per volt per second. A very easy question I gave you. And this is from your previous year NEET only. Now some other questions let's do from it. So only two students have attempted it correctly, Alia and Anna, right? See, these two, they are connected by a single wire when there isn't any breakage. So it means they are connected in series. So R1 will be 3 plus 3, which is 6 ohms. Now this is rather, instead of these two, this is connected in this way, 6 ohm. So you can notice this 3 ohm and 6 ohm, they are connected in parallel. So finally R equivalent will be what? 6 into 3 by 6 plus 3. So 18 by 9, that is 2 ohms. Current is current is unknown, voltage is given as 3 volt. So use V is equal to IR. When you will use V is equal to IR, I will be V by R, that is 3 by 2, which is 1.5 amperes. So correct option is C. This is a question from your AIEEE PYQ. Abhinav, right answer. Others also, let me know your answers. Only 2 students could attempt it. Only Abhinav and Anna have. Their answers are right. See, class, use this relation which we have seen. Alia is also correct. Good. See, the resistance is equal to rho L square by V, right? If we write area as L square by V, we can write it R is equal to rho L by A, we write no. And area is length into length, volume by length. So that this is how we can write. So the usual relation of resistance with length is directly proportional to it. R is directly proportional to L square. See, if let's say initial length, let's say this is L1. All right. So final length will become, it's 100%, it has increased. So it will double. Completely it has increased. No, it's like L1 plus L1 into 100 by 100. That is L1 plus L1, that is 2L1. So it has doubled. So what will be the ratio now? You can take the ratio easily and try to use the ratios methods only in your NEET, because these things get easily cancelled. So R2 by R1 if we write, that will be L2 square by L1 square, which will be equal to 4L1 square by L1 square. So this gets cancelled. So new resistance is 4 times the earlier resistance, right? So how do you calculate the percentage change? Final minus initial by initial into 100. So this is 3R1 by R1 into 100, which is 300%. Like this you had to calculate. Those who couldn't, just note it down. This is an important question. Do mark this question as important, all of you. And I'll share some more questions and note it. Yes, Abhinav, correct. I'll wait for some other answers as well, then I'll discuss. Anna, just check your calculations once again. Yes, class. See, let's just assume one resistor to be R1, another resistor to be R2. Then we'll relate it. So in series combination, S will be equal to directly R1 plus R2. And when we'll talk about parallel combination, P will be given by R1 into R2 divided by R1 plus R2. Right. Now see, if we go by this relation, S is equal to NP. So we'll substitute this, put values of N, S and P. That is R1 plus R2 is equal to N times R1 into R2 by R1 plus R2. S is equal to NP. This is what is our equation. So if you rearrange the terms, this will get multiplied. So this can be written as R1 plus R2 whole square equal to N into R1 into R2. That's how we can write this if we rearrange it. So let's open this up using identity A plus B whole square. So R1 square plus R2 square plus 2 R1 R2 is equal to N R1 R2. This is what we can write. Now, see, let's bring N also towards this side because this is common. So R1 square plus R2 square plus 2 R1 R2 minus N R1 R2 is equal to 0. So from here we can take R1 R2 common. So that becomes R1 square plus R2 square plus if we take R1 R2 common, this will be 2 minus N will be left equal to 0. Now, what we can do to get the equation, no, we can divide the entire equation by R2 square. If you divide it by R2 square. So it's like R1 square plus R2 square plus R1 R2 2 minus N equal to 0. Divide it by R2 square. Now, wherever we are getting, let's do one thing. This R1 by R2 is becoming very common everywhere. Let's do one thing. Wherever we get R1 by R2, we'll put it as K. So at least this will get simplified. Because see, if I use split the middle term here, you will not be able to understand this. So let me write it as K. Now you can easily understand. It's like K square plus 2 minus NK, and this gets cancelled. This is plus 1 equal to 0. Now this seems like at least a quadratic equation to you. This was difficult to see it, like to look at in that manner. So now you can at least solve this equation, k square plus 2n 2 minus n. So for real value of k, if you use the entire term, d should be greater than 0. So see, 2 minus n whole square minus 4 should be greater than or equal to 0. For the minimum value of n, what all should we put? 2n minus n whole square minus 4 equal to 0, because this is the minimum value. If you exceed the value 1, 2, 3, 4, out of it, the minimum value will be 0. So we'll equate it to 0. So again, open this using the identity. That becomes a square 4 plus b square, that is n square, minus 2ab. 2 into n, that is 4n, minus 4 is 0. So 4 gets cancelled. N square is equal to 4n. This gets cancelled. N is equal to. That's how you had to solve this question. Note down the solution. All right, Samira, at least do one thing. Rest of the questions have been missed, but at least note down this question or take the screenshot of it. Because how will you know what's the solution about is about? So just at least write down the question quickly. And text me done once you have written it. Yes, Iram, right answer. Others also try, then I'll discuss. Abhinav is also right. Abhinav and Iram have given correct answers. Last 1 minute class, then I'll discuss it. All those who are trying, hurry up. Let me know your answers. Samira, slight error. Slight error is there in your answer. Check it again. No, Alia, no Anna. So only Abhinav and Aram have given the correct answer. Look, all those who are getting confused. See, I'll draw it first. Wait. So this is a rod. L is the length of each part. L is the length of each part. Resistivity, let's say rho 1, rho 2. This is what is given. And yes, this is also mentioned. The area of cross section, this is also mentioned. This is, let's say, this is A. Right. So one formula which we have studied for resistance, R is equal to rho L by A. So this is going to be rho 1 L by A. R2 will be rho 2 L by A. Now look, if they are connected in series, so R equivalent will be R1 plus R2. So rho 1 L by A plus rho 2 L by A. That's how we can write it. Now look here. Net effective resistance of the two wires, if you write, you will get this part. But one thing also from here, R equivalent also, no, we can write. R equivalent also we can write. What is the net what is the net length? 2L, L plus L. Net area of cross section will still be A. Net resistivity, we can say, let's say that net resistivity is rho, because you cannot add it directly. So entire is rho. So R equivalent will be what? R equivalent will be rho L by A, we write. So rho 2L by A. This is for entire wire. Rho L by A plus rho 2L by A. L by A, L by A, L by A gets cancelled. So 2 rho is equal to rho 1 plus rho 2. But do we need rho? Conductivity. This is resistivity. What do we need? Conductivities. And yesterday we have discussed this. Sigma is equal to 1 by rho and 1 by rho is equal to sigma. So sigma is equal to 1 by rho. So what can we write? We can write this as 2 by sigma equal to 1 by sigma plus 1 by sigma 2. So that makes it sigma 1 plus sigma 2 by sigma 1 into sigma 2. So 2 by sigma this is. So sigma will be 2 will get multiplied here and this will come. So this is going to be 2 sigma 1 into sigma 2 divided by sigma 1 plus sigma. So this was option A. It was option A. C class, those who were committing mistakes, no, you must have not taken R equivalent. R is rho L by A. So net area will be, area of cross section will remain same. Resistivity we do not know, so we took it as rho. And L double 2L. So R equivalent also you have to substitute it in this way. I think 2L, those who haven't done are getting C option. Note it down. Any doubts you have, get it clarified. Yes, any answers for this question? Nobody has answered till now. Not a single answer.
Ma'am, can you solve it? I don't know how to approach it properly.
Okay, Ram. Alia has tried, and yes, Alia, your answer is right. Okay, others, let me discuss it. See, when this is given, no, don't think this is in the form of circle. It is given you in the form of circle, but can we solve it in the form of circle? No, we have to solve it in the manner we are habituated. Right. So when it says 12 ohm per meter, in 1 meter it's 12 ohm. We have to find out what is the resistance of wire. Look, class, what is the circumference of this circle? 2 pi r. Circumference is 2 pi r, and radius is also given. Radius is 10 centimeter. So 2 into pi into 10 centimeters, or divided by 100. So 2, 5. This becomes pi by 5. So entire circle has pi by 5. So we know for 1 meter, what is the resistance given? 12 ohm per meter. This means for 1 meter, resistance is 12 ohm. So for this much meter length, resistance will be 12 multiplied by pi by 5. So that is 12 pi by 5, right? But see, this is for the entire, this much ohms, no, this is for the entire circuit. We want to find out across these diametrically opposite end. So half of the circle, so fine, for half of the circle, we'll half it. For semicircle, we will half it, that will be 12 pi by 10 ohm. So it means, now see, this portion is 12 pi by 10 ohm, and this portion is also 12 pi by 10 ohm. Instead of you drawing it like this, we'll draw it in the systemic manner, the way we draw parallel circuits. Then your question won't look difficult. It's like this is 12 pi by 10, this is 12 pi by 10, and here is your A point, here is your B point. Whenever no, it says 2 points are given. The way in this question also 2 points were given, A and B. Just connect a battery. Just connect a battery to the points like this. Then no, it will become clear to you. Now instead of making it as round, I can just make it in this way in a standard form. Now we know how to solve parallel circuits. Now you can easily solve this. Equivalent resistance will be what? See, equivalent R equivalent. This is the same identical resistors are there, no, identical resistors. So you can divide it by the number of resistors, that is 2. You can directly divide it by 2. Or you can do your proper long method, 12 pi by 10 into 12 pi by 10 divided by 12 pi by 10 plus 12 pi by 10. But this is not your board exam that you have to show your calculations. If number of resistors are equal, not equal, identical, it's not necessarily to be equal. If they are identical, then equivalent resistance is given by resistance divided by the number of resistors. Here we just have 2 resistors, so into 2. This gives 6, so 0.6 pi. So that was, I think, our option A. This is how you solve this question. Note down the solution and text me done once completed.